Here we're asked to solve a linear system by graphing. Let's begin by finding the equivalent system where the equations are in slope-intercept form. To do this, from the first equation, we can simply add x to both sides. When we do that, we'll be left with y equals x plus 6. And we can write that in. Next, let's determine slope-intercept form for the second equation. To do this, we begin by subtracting 5x on both sides. That'll leave us with 2y equals negative 5x minus 2. Solving for y, we next divide both sides by its coefficient, 2. And we have y equals negative 5 halves x minus 1. So this is an equivalent system where the lines are written in slope-intercept form. This will help facilitate the graphing process. Now, when solving by graphing, you want to make sure your rectangular coordinate plane, your scale, and your tick marks are as nice as possible because accuracy here is very important. Let's look at the first line. In this case, we can tell by inspection that the slope is 1. We can think of that as 1 over 1. Remember, that's going to be my rise over run. The y-intercept in this case is 0, 6. So from the y-intercept, we'll mark off the slope rise 1 and run 1, and that'll give us 2 points. 2 points determine a line, and we can connect those with a straight edge. Now the slope for the second line is negative 5 over 2. And the y-intercept here is 0, negative 1. So from the y-intercept, we'll mark off the slope, we'll rise negative 5, or we'll go down 5, and over 2, and we'll run 2. So that gives us a point right here, and we'll go ahead and connect those with a straight edge. After graphing both lines on the same set of axes, we can determine the solution by finding the point of intersection. In this case, the intersection appears to be the point negative 2, 4. Now we should check that. Let's make sure negative 2, 4 satisfies both of the equations. Substituting negative 2, 4 into the first equation, we'll have negative 2 plus the y, which is 4, or 2 plus 4, and certainly that checks out, 6 equals 6. Now substituting into the second equation, we have 5 times negative 2 plus 2 times 4. We'll see if that equals negative 2. Negative 10 plus 8. Well, that checks out as well. Negative 2 does equal negative 2. So the point negative 2, 4 satisfies both of the original equations. And we found that point by graphing both the lines on the same set of axes. So the solution by graphing is negative 2, 4.